Alrighty, sports fans, look at this. Transformations. You betcha. We have to know how to shift it up and down, left or right, stretch it horizontally, stretch it vertically. We got to know all of these things here, folks. We got to remember them because it's based on the same stuff you did before. Look, the rules that apply to transforms of many types of functions still apply to the transformations of sinusoidal functions as well. There's just a couple little tricks here. There's not much. So think about it. If you had some sort of y equals to the f of x, you can transform this. And since we're going to talk about vertical translations, we're moving up and down. You know from the original unit, this is taking a function and adding a value to it. We're going to call that value d. That d is going to move it either up or down based on its sign. Ah, ha, ha, ha. So the vertical movement, or what we call the vertical displacement here, is the movement up or down of this wonderful function. So we're going to move this whole thing either all up or all down. Think about this. That means that d value that you put here, yes, applies to the sine, or it could apply to the cosine, or it could even apply to the tangent functions. Oh my goodness. Most importantly, though, is that remember, all you're doing is moving it. So you're not changing the size. You're not changing the size of this. The size is not changed. You're just moving. Got it? Okay. So the question then, if that's the vertical displacement, you have to remember, if it's positive, it moves up. If it's negative, it moves down. But the point is there a special way of figuring out the d? Yeah, look at the original diagram. Remember this. Let's look at a sine one. You know a sine goes up and it goes down. One complete function over 2 pi, right? Now, think about this. I have not changed anything here. I have not changed the period. All the periods based on b, b's are all ones. So guess what? The period for cosine and sine are all going to be 2 pi. For tangent, of course, they're going to be pi. We'll talk about that when we get to tangent later on, okay? Not right now. Now, the cool thing that I want you to see here is that, remember, if you look at this, which was our original sine function, so y equals to sine of x, right? What's going on with this guy? Look, you went one up, one down, but you notice something that this is like saying plus 0. 0 meaning that you have not shifted up or down at all. So where is 0? That is 0. So what does that mean? That 0 is actually referred to as the midline. Aha! Yes, the midline, the middle of this wonderful little graph that we have going right here, correct? You with me? Okay, so what does that mean? What if I shifted this? What if this is now way up here? How do I figure out that midline? Well, that midline is really easy to figure out. What you do is you take your top, you take your bottom, you add them together, and since it's a midline, it's like figuring out an average. What are you talking about? Think about it. If you had 80% in one test, you had 90% in the next test, wouldn't you add them divided by 2 to give you 85% as your average? Well, same thing goes with this. Take your upper value, add it to your lower value, divide by 2, you find your midline. And guess what that midline represents? Your d value. Yep. Okay, so I've got it written out for you here. You can see it. There it is. The formula for determining the vertical displacement, the d value, is you take your max, add it to your min, divided by 2, and that is your midline. There's your midline right there. And that's the d that you'll actually pop into this wonderful little formula right there, or right there, or right there when we get to the tangent part of it. Okay, with me? Great, so I'll shut up. Let's go on to the actual question. So here we go. First things first, this is on the same axis, sketch and compare the graphs of the following functions. Okay, but there is an interesting thing here. There's a domain restriction that you have to realize. Remember these solid brackets. The solid bracket means to include that value. So we're going from minus 2 pi to exactly 2 pi. So we're going from 2 pi and minus 2 pi. We're going from those two sections here. So, and also remember, what does the sine graph look like? I always draw it out just to remind myself the sine graph looks like that. And remember, we're dealing with we're dealing with a period of 2 pi. So this guy has to do the entire cycle within 2 pi. Now, remember to break this down. So we're starting here at 0. We're ending up here at 2 pi at 0 again. So that's this guy right here. That's what we're dealing with. Remember what happens. In the middle of this guy, you're going to get a cut. Well, there's the middle right there at pi. You're going to get cutting the axis. In the middle of that, there's your maximum. Okay, so where's the middle? 1, 2, 3, 4, 5, 6. So at 3, 1, 2, 3, there's your maximum, and you know it to be 1. Why? Well, hey, don't forget it. It's a unit circle. A unit circle means your maximum height of this guy is going to be 1 because your radius is 1. So there's your maximum. There we go. Bada boom. Then you know it's going to go from here. There, we pass the maximum. We're going now back to 0. That's this section right here. Now we're going to the minimum being minus 1, right? Okay, so right in the middle of this. So 1, 2, 3 was the middle. So 1, 2, 3 is the middle. There it is at minus 1. And there's the rest of your graph. Boom. You should be able to do that really lickety-split now. That shouldn't be affecting you at all. Now, okay, let's do the negative portion of this. All right, so there's where you're going to cut. There's where you're going to end. There's your two endpoints, here and at negative 2 pi. Now, 1, 2, 3, there's your middle. And 1, 2, 3, there's your other middle. Perfect. So count how many ticks you have and try to find the midpoint of that. And then draw a real pretty graph. Notice I didn't put any pi over 6s, pi over 4s, pi over 3s. No, the reason why is because I know the sine graph looks like that, right? So what's the point of putting all the other values in there? I just deal with those quadrantial angles, okay, and the quadrantial numbers. All right, so let's go and do this one. Which one? That one. No, this one. Let's look at this. Look what this means. Up by 1. So in other words, take every single point of your original graph, this guy here, and just increase it by 1. Okay, so there's the original graph. We're going to increase it by 1. There's the 1. We're going to increase it by 1. There's the 1. We're going to increase it by 1. There's a negative 1. Increase it by 1. There back to 0. Increase it by 1. And look what you get. You get a really beautiful looking graph that's 100% congruent to the green graph, just up 1 value. Okay, do the same thing with this. Take this guy, increase it by 1. Take this guy, increase it by 1. This guy increased by 1. This guy increased by 1. And look, same nonsense as before. And look at that. Now, do you remember how to calculate D? I know we know the D is 1, but I want to prove to you that that calculation works. You take the maximum being 2, add it to the minimum being 0, and divide by 2. 2 plus 2 is 2, divided by 2 equals to 1. Well, lo and behold, there's the value, but check this out. Watch this. If you actually draw it in, watch this. I'm going to draw that value in. Here we go. Ready? Right at 1. Look at this. Right at 1. Look at that. There's our halfway point, right? There's our amplitude. Amplitude being 1. Amplitude was up front, right? Do you remember? Okay, look at this. Amplitude, of course, still being, even though it's a negative, we still refer to it in the absolute value. That is still an amplitude of 1. Isn't that wild? So, look at this last one. Okay, let's do the last one. It says every point is now down by 2. So always go from the original guy, this guy here. So we're going from the green graph. Okay, green graph, and we're going to go down every point by 2. So this point, down by 2. This point, down 1, 2, to here. This point, down by 2, back to here. This point right here, down by 2, down to here. And then finally this point, down by 2. Look what we have. We have a beautiful looking graph going like that and all the way to there. Do the same thing to the opposite side. Starting again, remember, you have to start from your green graph, which is this guy, down by 2. There we go. This graph here, down by 2. All right? Boom. This one, down by 2. This one, down by 2, which brings it back to here. So again, completing this guy out now, you're going to get something that looks like this. And to prove that that D value works, you know the D value is right here. The D value is -2. But to prove that it actually works, take your maximum, which is -1, add it to your minimum, which is -3, right? And divide that by 2, just like you'd figure out an average. So this works out to be -4 divided by 2, which is -2. And lo and behold, look at this. Right smack through the middle of this graph at -2 is your center line, your midline. Isn't that pretty? That's how you figure out the vertical translations.